So thank you, Andrea, for your kind presentation, and thanks for the invitation. So I will discuss about PFAS, new PFAS, and I will discuss about such a kind of contamination in food contact materials. My company is focused on packaging and something different from packaging, something that we call food contact materials, so frying pans and every kind of surface that comes into contact with the food. Just a few words to describe my company. I decided to build my own company 6 years ago. Now we are a team of average 15 people. We are located in Pistoia, and we are going to change our location. You can see here some technique that we have into the lab. Some technique are located into the new laboratory that we opened 2 years ago, and the lab now is also accredited, is in Brescia, and in Brescia we perform the materials characterization, and then we also have an office in Cuneo. Cooperation, we have many cooperation with Italian and also with foreign university, with Bangkok University, and also with the Yeditepe University in Istanbul. And of course, we participate in technical meetings and technical commit at and also European level. We are not just a provider of testing, we also are focused on consultancy, regulatory, and so on, life cycle assessment studies. So that's why we also created another company that is food contact services. So we can start, we will see something about the definition of new and old PFAS testing approach on food contact materials, and then we will have we will discuss a case history of a sample in paperboard where we faced many troubles to detect PFAS in liquid mass testing. First of all, we are focused on food contact materials. Everyone, when thinks about food contact materials, maybe thinks about only the final packaging. But of course, we do not have only the final packaging. Many times contaminants can come from the industrial packaging, from also the surface of machine, and also from items that we daily use into our kitchen. And anyway, the rule for food contact materials, it's always the same. There are not limits that are focused on the total content. We must perform migration testing, and we must identify substances and evaluate quantities that could endanger the human health. So it is so important the content, but what we must evaluate is the migration into the food and also the exposure of the consumers. That's why we must perform the risk evaluation, then the risk assessment and the risk management, taking into account the hazard, so the substance that is contained into the item, the exposure, so the migration, and also the exposure related to the daily intake of the consumer in that specific area. The principle is the classical example is that we could have a very hard and high hazard like this tiger, and but if we don't have any kind of exposure, there is no risk. If the tiger is free, there is also the exposure, so we have to evaluate the risk. That's why we must perform migration testing. So we must evaluate how the substances move into the material and into polymers. So we use the first and second fixed law to evaluate the migration into the material, and then we have to identify and quantify substances into the simulant or also into the food. Before to start, just some images that are referred to an inappropriate use, because many times we have troubles that are referred to very funny but wrong use of the food contact materials. For example, for the items that you can see here in the picture that are sold to be used for example, for muffin preparation. Many times we have in that items also some meat or some acidic food into contact, and you can understand that in that case we have sometimes some fuss, and the migration it's very, very different if it is compared to a muffin or anyway to a bakery item. Some example that we face every day, also the direct contact with the printed material. It is forbidden by the legislation, but we know that every time when we go at lunch, we put some food into contact with some items that are printed. So one of the highest risk to take into consideration is the inappropriate use. So let's start. When we have to evaluate the conformity of food contact materials, we have to deal with materials, with substances. We have to evaluate the distribution of the item, then the regulation, and of course, finally, we can define the technique, test method, testing condition. And we have, usually we talk about IMaSS, so intentionally added substances, so raw materials, monomers, solvents, and so on, coloring, something that my sample. But we also have to detect IMaSS, so non-intentionally added substances, so additives degradation, polymer degradation, residues, neoformed products, impurities, and also, of course, some new PFAS. I'm going to skip this slide because, of course, many colleagues today will describe categories of PFAS, but of course, we all know that there are new substances, there are a very large number of new PFAS, and the challenge is to be able to detect also the new substances that in this moment are not so clear, and substances where we are not able also to find the standard to perform the targeted testing. Some papers on food contact materials and PFAS clarify that we can deal with polymeric PFAS and also non-polymeric PFAS. So sometimes PFAS are linked to acrylate, methacrylate, and urethane, and other kind of polymers. And in this case, it's very, very hard to break the chain and to be able to have detection in the test. And we also can have some non-polymeric forms of PFAS. About the historical use of, I found very, very interesting this review. Here we can read that the carbon tetrafluoride, that was the first perfluorocarbon, was produced many years ago, and then some research have been done, and then finally we all know that DuPont was the first company to commercialize PTFE. And in the same review, we can find some tables with the different kind of application in our field in food contact materials. So I tried to clarify that usually we have three kinds of food contact item. we have to test parts of machinery like elastomers, like some parts that are used in food machine. For example, we can see here some components that are used to produce the pasta. And all the times we have to deal with coated materials, so also the mixture that can be used to perform the board materials. So typically three kind of different items. Starting from paper on board, we can see here in this paper how the effect of the perfluorocompounds can be realized. So we can see here the oil and the water droplet and the change is disposed and how we can have the effect to give the property of resistance to water and to also fats to the materials. And it's interesting that many times where we find a low concentration of FAS, we have some troubles. For example, this was in this picture my hand. We tried to test the performance of such kind of dish, and you can see here that after some minutes there is not resistance to with food. And sometimes also we can experience some troubles. We can have some sticking. For example, in that dish we have some polenta and some sticking of the surface of the sample, and also performing the test into microwave, we can have some burning into the lab. So we are in the period of what we call the paperization. So every company is trying to eliminate plastic in order to use only paper, but of course it's not easy to have the same performance if we have some cellulose fibers. About regulatory enforcement, the first the decision about FAS in Europe are in 2006, and also in USA we had the first message that was trying to invite companies to reduce FOA. And I don't know if you know this movie. I also read the book in this summer. It's very, very interesting because in the waters, all the history of what happened in that specific place where DuPont was producing, and there was a lot of sickness into animals and also into the people. And in the movie and also in the book, it is clarified that at the beginning EPA was trying to deny toxicity, but then we can see that something like 10 years ago we had the first release of the 537 EPA method. That it is one of the methods that are more used in, of course, in our field. About regulatory enforcement on food contact materials, currently from FDA we have some indication of specific use. So we can use in USA some fluorinated compounds, but only some specific compounds. And the situation is different considering the different states in USA, because locally there are a lot of decision to ban totally FAS from the market. And in Europe, in this moment, the situation is not clear. We have a ban in Denmark for the total quantity of fluorine, and we have the limit only for the FOA in France for paper food contact materials, and we have in the REACH regulation total content limit. And this is something particular because I already said that for food contact materials, we do not have to evaluate the content, but the migration. So sometimes some items that are safe as food contact materials are not respecting the REACH regulation. As I said before, locally in USA, we have some for example, we can see here from our newsletter the decision related to California, and if we check the document, we can see here that what is banned is the presence of PFAS evaluated as 100 parts of million, so 100 ppm of total organic fluorine. And the same limit we can find in the Denmark legislation on paper on board. In this case, we have 20 microgram, but once again, we are not talking about PFAS, but we are talking about organic fluorine. And one of the big challenges for companies is to show that the item is compostable and that is respecting this standard that is related to composting and biodegradation. And in the standard, we can read that there is a table with some limits for some elements, and there is the fluorine limit of 100 ppm. You can see here in this slide, this is one of many samples that we test. We do not perform the test internally. This test is performed in Milano in the InnoHub laboratory. It's the test of the combustion, and then the fluorine is detected with the chromatography with the Dionex, to understand, and we can have a result that are very high, a lot higher compared to the limit. That's why in USA and also in Europe, the legal entities that are given the mark of compostable decided to change their approach. So it is not necessarily only the testing, but we can read here that the producer also need a statement of non-intentionally added fluorinated chemicals. And also for the TÜV Austria standard that in Europe is a reference for this kind of mark, we can read that the applicant must sign a self-declaration that no PFAS are added into the product. The reason is the test is giving a very different result. The same sample, you can see here the very hard, large amount. The same sample was sent in other labs and the results were very different. So not so easy to standardize also the total fluorine quantity. And then we go into deep to some rumors that we had in Italy. So we can see here, this is the article of Altroconsumo that is referred to the BEUC study. You can see here the study, and we can read that at the end of the day, the total fluorine analysis was performed, performing the test that I was describing before, and the reason we can read that the targeted analysis, it's only able to detect those PFAS compounds for which standards are available. That's why it's better to perform the total organic fluorine testing. The same conclusion was published in the other article published in the Salvagente, and also in this case, the reason was that there is a very large amount of substances. That's why it will be complicated. I also translated here. So it will be complicated to test each substance to decide, to define the compound use. Of course, we all know that it's true, but there are also other reasons, because many papers are clarifying, like the paper that I inserted in this slide, that many times we can find a very, very large amount of total fluorine, total organic fluorine, but in the liquid mass testing, also in gas mass testing, we are not able to detect PFAS. So this is the real reason for this kind of approach. So I'm going to leave now the paper on board materials, but we will have then a case history on paper on board. Now I'm discussing the other category of samples that we test into our lab, and we are talking about fluorinated polymers, and many times are related to food machine. So we have the food machine producer, or sometimes also the food company that is asking to us to detect PFAS. And we can see that in the migration, many times there are no problems in the migration testing. Now I will discuss a little bit the sample preparation, because this is a typical example of consumer good item. And for consumer good, we have this standard. I know this standard since the beginning, when it was released. I was working in Intertech, and we can see here in this internal slide that I was sharing with my colleagues. This is the extraction condition, and then the liquid mass testing. So extraction after ultrasonic bath extraction with methanol, and then testing using liquid mass. And also the standard is asking to use the time fly. So in that period in Intertech, there was just one instrument of cutoff, so it was not easy to respect the standard. The evaluation, of course, is that you must have the instrument, but to evaluate a large number of compounds, you also need a library. So this is the reason of our cooperation, and that's why I also decided to disturb again Andrea. Every time that I was changing my job, I was disturbing Andrea for some research. In this case, cooperating with SciEx, we started to build a library focused on contaminants of food contact materials, and we also have a specific compound list for FAS. And I also added the picture that you already seen before, but I also have the updated version. So here there is my father with Andrea and me in our lab. And also a big part and a big contributor in this project is coming from Philippe, that is here today. So finally we completed the project, and we released the library, and internally we continuously update the library. We have 2 resources dedicated to the continuous improvement of this library. So as I said before, for that kind of sample, ultrasonic bath and then methanol, and then the targeted testing, referring to the list of PFAS that are inserted in the new version of the EPA method, and also untargeted testing, referring to our library. As I said before, we do not have troubles to respect the law, considering the migration. Sometimes we have some troubles to respect the ECHA request that is referred to the content of some FAS into the material. And we can read, this is a part taken from the legislation related to the ECHA, and we can read that the limits are referred also to mixture. That's why for our customer that are producing frying pans, sometimes we have to test also the mixture, so the raw materials that they use, because they know that the final item is respecting the legislation, but of course they have the doubt that they are receiving some raw materials that are not respecting the legislation. That's why we perform the test also for the raw materials, and it was not so easy to define the method. Also, Andrea helped us in that case to try to purify or just dilute the sample, and also to have a good recovery for each FAS that we were using. That the list was already they already said the list of the EPA method, and so we can perform and we do perform the targeted testing. You can see here the column and also the chromatographic condition, and also the untargeted testing. And the same approach, we have the same approach for same kind of producer. They have the request to test the wastewater, so we perform a targeted testing and also untargeted testing. And about the limits, the local authority asked to our customer to refer to the proposal of legislation about FAS that is referred to water for to drinking water. Of course, we are talking about very, very low limits, but currently this is the only reference. Now I will focus a little bit more the attention on paper materials. About paper on board, every lab in our field is referring to the literature, to the papers that are referred to the research of Xenia Trier. This is the first work that was describing the extraction of the sample. Anyway, the approach is the same, so methanol extraction. And we can see in that document also some specification about the instrumental condition, and also it is clarified that it's necessary for the lower molecules also to use the gas mass approach, and there are also other studies that are referring to gas mass testing. That's why in our lab we also perform some gas mass screening. And now I will conclude with this case history. This is referred to a comparison that we presented 1 year ago in the European meeting on the packaging sustainability. And we've been asked to compare the safety and also the LCA, the life cycle assessment study, comparing a tray in polypropylene with the tray in bagasse pulp. And we found, considering the LCA, the same conclusion that are described into this document of the Union Nation. Find that also considering the environmental point of view, if we take into consideration of the categories of impact, it's we have a worst impact from the environmental point of view, considering the bagasse tray. And comparing the safety, this is the risk assessment on the polypropylene. The item is safe, no problems. And for the bagasse pulp, we found some heavy metals, but also we found some FAS in gas mass screening. And as I said before, this tray was marked the compostability mark, but it's not possible because considering the limit, we have a very, very larger amount of total fluorine, so large amount of fluorocompounds. So at the end of the day, we have been able to show and to have also a good satisfactory result for our customer, and we were dealing with a category of customers that were trying to show that it is still better to use the plastic item comparing to the paper and board bagasse tray item, considering the safety from the environmental and also the safety point of view. But in our lab, we were not so happy, me, Filippo, and all the team, because we wanted to also to detect some components in the liquid mass. And unfortunately, in the first result, you can see here that no polyfluorocompounds were detected in the LC cutoff screening. You can see here the sample. It was quite impossible to wet the sample. It was totally water and solvent resistant. That's why we decided with the customer to go a little bit into deep and to try to understand also the structure, and also if in the material that was some other polymers or other components. So we performed some image, and we can see here that we from the external to the internal. Here we can see the typical paper fibers, but if we go from external to the internal of the sample, we can see some fibers that are not typically the fibers of paper and boards. That's why they are very similar to the viscose, so the regenerator cellulose. That's why there's been something particular to produce this item. And also performing the infrared and also DSC testing, we only have signals typical of cellulose. So it's this is matching our hypothesis that we are dealing with regenerated cellulose. And we also decided to go into deep, and we tried also, helped by Andrea, to also test the sample referring to the TOP, so to total oxidable precursor assay, and also performing other kind of research into literature. There is a publication of some months ago, it was in December of 2021, that was clarifying how to prepare the sample. And I found also very interesting this paper. This is referred to soil, but it's very interesting to see the selectivity from NMR, top assay, and of course a total fluorine, different selectivity in the test. And what we did is to try to perform so the top testing and also the treatment with methanol and sodium hydroxide. So this is I just decided to take the technical report and to put it into the slide. We can see here the chromatograms. No better results treating with the methanol, but some results using the permanganate treatment. We also studied other papers, and we tried to also test the item using another oxidant, the persulfate, and this is so the final method that was performed into the lab. So metal extraction, and then concentration, and then we added the potassium persulfate, and then SPE purification and testing. And we can see here the different results. So we can see here that nothing with the simple methanolic extract, some result with the treatment with permanganate, and better result with the less treatment with the persulfate. So at the end of the day, our customer was very, very happy of the result, because it was possible to show that there was the total organic fluorine, but also some FAS were detected. Of course, the quantity it is not comparable of the quantity that were found with the TOF analysis. Last slide, just just to show one of our initiative. The classical situation that I think everyone must face is when the customer is saying, I gave the same item to different labs, but I receive a very different result. This is a classical situation in the labs. That's why a team, me and mostly Anna Bortoluzzi, decided some years ago to create this proficiency problem-solving team. It's a company, but it's not a company to, I would say, to make money. It's just to exchange knowledge and samples and to be able to help companies where we have some difficulties to decide the testing approach. So this is the net of experts that just want to share technical and analytical information, and the company realized a tool to participate to this kind of interlaboratory trials that are respecting the ISO standards, and there is a tool to have the total anonymity of participant in the interlaboratory. And there's been already some trials. For example, this was on mineral oil in soils and another trials on solvents on flexible packaging. This was the last one on heavy metals on ceramic items, and after the testing, the team was able to release a standard, and now this is the reference standard to test heavy metals in vitreous and porcelain items. That's why my proposal, we have a lot of samples. We checked some days ago, we have a large amount of samples. So if someone is interested to participate to a trial, to decide to find together the right approach to be able to find and to detect more and more PFAS from that kind of paper food content materials. Thanks for your attention.